center of a circle or the center point of a circle has equidistance that is equal to the radius, and the measurement of radius is twice the measurement of our diameter. And as I have said, we can name the circle by its center point. So a circle is named by its center. For example, if the point is A as the center of a circle, then the point of the circle is circle A, or the name of the circle is circle A. So we have different parts for a circle, has a special name depending on its characteristics and its function in the circle. So we have the arc. We have two type of arc, which is the minor arc and the major arc. Arc is the part of the circle that is named by its endpoints. So if we're going to have a graph of a triangle inside of a circle, the endpoints of that triangle is the name of the arc. Major arc, that means that is the largest arc in the circle. Minor arc is the smallest arc that we can form in the circle. The other parts, we have the radius. We already know what is radius. That is a line segment whose endpoints are the center of a circle and any point of the circle. So the endpoints of a radius is the center of the circle and any other point in the circumference of the circle is radius. And we have the diameter. Diameter is a line segment that passes through the center of a circle and whose endpoints lie on the circle. Means the diameter has endpoints in the circumference of the circle, and diameter is a special type of chord. Okay? And diameter is the longest chord that you can have in a circle. So that is diameter. We have the chord. Chord is a line segment whose endpoints are any 2 points on a circle. It has the same endpoints when it comes to diameter, but chord can be drawn any part of the circle. Okay, so that is the basic part that we can have in the circle, which is the arc, the radius, diameter, and chord. And we have other parts of a circle, which is the central angle. When we say central angle, that is a circle, an angle formed by two radii, wherein the vertex is the center point of the circle. That's why it's called central angle, because its vertex is the center point of your circle. And you also have the sector. When you say sector of a circle, that is the part of a circle enclosed by two radii and an arc connecting to them. Means when we say sector, that is the space. This part is your sector. Sector being formed by a two radii connected by the arc. Okay, that is sector. So the sum of the measures of all of the central angles in a circle is equal to 360. We can say that there are 360 degrees in a circle. You know already that the total measurement of the angle of a circle is 360 degrees. That's fact. We cannot change that concept, that the total or the sum of the angle of a center is 360. So for example, we have this circle and we're going to name the parts of a circle that we can identify in this circle. So let's start with the radii. What are the radii that we can have in this circle? What are the radii that we can have in the circle? on the screen. So in naming radii, you name the radii from the center point down to the point in the circumference of the circle. For example, radii or line segment GB. That's one of the radii. We have line segment GD. That's another radii. Line segment GA and line segment GF. So that is the radii that we can have in our circle. For the diameters, we only have two diameters. In naming diameters, you name the diameters by its endpoints. You have line segment BF and line segment AD. Or you can name it as line segment FB and line segment DA. It's just the same. So that is the diameter that we can have in the circle. For the chords, we have the diameter itself and the line segment AF, that's the chord, line segment CE, and line segment BF, and line segment AD. As you can see, the diameter that we have identified a while ago is also included as part of the chord of our circle, since diameter is a special type of chord. So that is the part of our circle. So let's proceed with the theorem. We have the special features of circle, which is the tangent. Tangent is a line which touches the circumference at one point only. So tangent line, feature of circle is a line segment where it only touches one point in the circumference. Okay, that's the special features of circle. Tangent. We have also the arc. We have already mentioned that one. It's part of the circumference of a circle. The major segment and the minor segment, or the major arc and the minor arc. So let's proceed with the properties of circle. So in the properties of circles, when angles, triangles, and quadrilaterals are constructed in a circle, the angles have a certain properties. So we are going to follow the certain properties of angles for us to be able to identify the missing measurement of an angle that is being constructed inside of our circle. So we have four properties of a circle depending on the type of shape or figure is being formed inside of the triangle. For example, an angle on a chord. So for example, that is so an angle that sits on a chord does not change as in the aspects moves around the circumference. So if a triangle is using the same vertex or the same chord, as you can see, this is the chord where all the triangles is being attached together. All of this angle containing the same chord have the same measurement or equal measure of angle. That's why they have 47 degrees, and 47 degrees. So when an angle where the vertex is at the end or at the circumference of the circle, so you can see this is the vertex of the three triangle that we have inside of the circle, if the vertex is in the circumference and they are sharing the same chord, all of the measurement of the angle is the same or equal. That's the first property that you can apply in circle. So we say angles subtended by a chord in the same segment are equal. So angles subtended by an arc in the same segment are equal. So that's other properties you can consider for looking at the measurement of an angle. If these three angles or the angles that we have or the triangles that we have in the circle is using the same arc in the circle, they have equal measurement of angle. So sometimes you cannot see a chord that is being drawn in the triangle, I mean in the circle. So kung walang chord na nakadraw sa circle, look at the arc of the circle. If they are sharing the same arc, that means all of the angles that you have inside of the triangle is equal. As you can see, they have the same arc, which is this one. That's the arc where the three triangles are sharing. So kung wala itong chord, for example, we erase this chord. So one of the identification that the three angles are equal is by looking at the arc. Okay? So another one is solving for the measurement of the angle A and B. So for example, we have 28 degrees for the other angle and 44 degrees for the given angle of the triangle. Imagine that we're going to draw a chord here. So if we're going to draw a chord in this circle, is this two triangle? This is the first triangle. And we have the second triangle, which is this one. Are they sharing the same chord? Nag-share ba ng same chord ang triangle that we have, which is this one and this one? The chord, for example, I draw the chord, which is this one, the broken line. So let me draw it properly. This is the chord, for example. One of the triangle is measured 28 degrees. So this is the first triangle that we have. Second triangle has a measurement of B, which is we don't know yet. So this is the second triangle. So looking at the triangle that we have, and I drawn an imaginary chord, are they sharing the same chord, the two triangle that has, yes, they are sharing the same chord. Kung nag-share sila ng same chord, it means angle B or B is equal to 28 degrees also, since they have the same chord. So let's try with the angle A. So let's say I'm going to draw another chord, since this one, this is the chord, imaginary chord that you can draw. So we have the angle A, another angle that we don't know the measurement of the angle, and we have a triangle that has an angle whose measures 48 degrees. 44, I mean. 44 degrees. So we have triangle A and triangle that has an angle which is 44 degrees. So I drew an imaginary chord. Looking at the two triangles, they are sharing the same chord, right? So that means angle A has a measurement of 44 degrees also. Okay. As you can see, you don't need to solve for finding the missing measurement of the angle. You just need to apply the properties. So if the two triangles is sharing the same chord and the vertex is at the circumference of the circle, that means they have the same measurement of angle. Okay. That is the first property of circle. Okay na tayo with the angle of a chord?
Yes.
So for example, we have tapos na tayo this one. Okay. So let's proceed with the second property of circle, which is the angle at the center or the central angle. So consider the two angles which stands on the same chord. They are sharing the same chord, but one of the triangle or one of the angle is at the center. So if that is the case of the triangle, the measurement for the angle is half of your central angle. So if one of the triangle is in the center, the triangle that is the vertex at the circumference of the circle, that is half of your central angle. That's why it's become 44 degrees. That's the second property that you can apply in finding the measurement of the angle inside of the circle. If one of the angle is at the center and the other angle is at the circumference of the circle, the measurement of this angle whose vertex is in the circumference of the circle is half of your central angle. So you're just going to divide the measurement of the angle of your central angle, which is 88. So that means it's equal to 44. So if two angles stands in the same chord, then the angle at the center is twice the angle at the circumference. For example, we have this circle. So let's say we have a circle that has a central angle. So a central angle that has a measurement of 84 degrees. And we're going to find the measurement of angle that angle A. So you can see one of the angle is in the central or in the center, and one of the angle is in the circumference of our circle. So applying the law of or the property of center angle. That means the measurement of angle A is half of our central angle. So half of 84 is equal to 42 degrees. That's the measurement of our angle A. That's how you can apply the angle at the center. It's always half. Whatever the position of the angle, as long as they are sharing the same chord, it's always half of your central angle. Okay? That's the angle at the center. The second property of circle. Let's proceed with the other property that you can apply in solving the measurement of the angle in the circle. So if the angle, for example, this one, if the angle stands to the same chord, then the angle at the center is twice the angle as the circumference. So for example, this one, our angle or the triangle that we have is this one. This angle is twice of your central angle. So in solving for the reflex angle, that is twice the angle at the circumference 2. Or we call the reflex angle as the inferior angle. So to find the measurement of your exterior angle is twice the measurement of the angle at the circumference. For example, if we have an angle the triangle or the angle that we have as a measurement of 56. To find, for example, the central or the reflex angle we have here, twice of 56, that's the measurement of your exterior angle. So 56 times 2 is equal to 112. That's your reflex angle. Twice the measurement of the angle at the circumference. Example, we have the circle. Applying the properties of angle of center. Example, this is our circle and it has an angle that measures 24 degrees and a central angle so if the measurement of this angle in the circumference is 24 degrees, the measurement of our central angle, let's say this is x, stands for x, the measurement of the central angle twice the measurement of your circumference angle. So it means x is equal to 24 times 2. Since angle at the circumference is twice the measurement of your central angle. So 24 times 2, which is equal to 48. So it means angle X is a measurement of 48 degrees. And the same, your reflex angle or exterior angle have the same measurement, which is also twice of your circumference angle. So kung ang circumference angle is 24 degrees, twice your circumference angle. So it's equal to 48 degrees also. Okay. So that's how you can find the reflex angle and the angle at the center of the circle, or the property angle at the center. Okay, now with the angle at the center property, let's have another example. For example, we have this one. So special case of angle of center, if the angle is at the diameter or one of the line segment of the triangle is the diameter, that means the diameter is straight line, so that the angle at the center is equal to 180 degrees. And one of the angle of that triangle is having a 90 degrees measurement. So that's the special case for angle of center property. If one of the line segment of the triangle is the diameter itself, means that the triangle opposite to the center is equal to 90 degrees, or it will form a right angle, a right triangle. So for example, we have the cyclic quadrilateral. So that's the third property that we can have in the circle, a cyclic quadrilateral. So a quadrilateral whose vertices lie on the circumference of a circle. We have the property for the quadrilateral where the opposite angles is equal to 180 degrees. So when you add the opposite angle of the two cyclic quadrilateral, it's equal to 180 degrees. Or we call these two angles as a supplementary angle, since supplementary is equal to 180 degrees. For example, if this angle measures to 85 degrees, so to find measurement X or angle X, you're just going to add 180 is equal to 85 plus X, since that is the property of cyclic quadrilateral. But if you add the two opposite angle of the quadrilateral, it's equal to 180. So 180 minus 85 equals to X. 180 minus 85 is equal to 95. So that's the measurement of the opposite angle of 85 degrees. We have 95 degrees. That's how we find the measurement of the angle if the shape that is being drawn inside of our circle is a cyclic quadrilateral, where all the vertices is in the circumference of our circle. So for example, we have another example, 60 plus 120 is equal to 180 degrees. So opposite angles in a cyclic quadrilateral add up to 180 degrees. So for example, we have this circle. It has a measurement of 60 degrees, and we're going to solve for the measurement of angle A and measurement of angle B. So applying the property of cyclic quadrilateral, so 63, once we add it to angle A, it will be equal to 180 degrees. Let's solve first for A. So A plus 63 degrees is equal to 180 degrees. So A equals to 180 degrees minus 63. So angle A has a measurement of 117 degrees. So that's the measurement of our angle 100 angle A. 117 degrees. So let's solve for the angle B. Since we don't have the measurement for this angle, we can use the property of the center angle. Using the angle of center. And it says in the special case of a center angle, once one of the line segment of a triangle lie as a diameter, that means the opposite angle of this center is equal to 90 degrees. It means this angle is equal to 90 degrees. Applying the angle center. If the line segment or one side of a triangle lies at as a diameter of the triangle. So if we have already 90 degrees and 63 degrees, so we know that 3 triangles is equal to 180. So we can solve now for angle B, which is equal to, once we add all this angle, it will be equal to 180 degrees. So angle B, 90 plus 63 is equal to 153 equals to 180. So angle B, 180 minus 153. So the measurement of angle B is equal to 27 degrees. So that is the measurement of our angle B. So that's how we can solve for our angle, applying the properties of the cyclic quadrilateral and the angle of center. Let's have another example. Okay, now with this example, I'm gonna clear the screen. For example, we have the circle. So for example, we have the circle. One of the angle has a measurement of 49 degrees. We have angle M and angle N. So if we're going to find the measurement of angle M, what properties are we going to use? To find the measurement of angle M, we only have 3 properties: the chord, the angle center, and the cyclic quadrilateral. So in this problem, since one of the triangle is at the center, we're going to use the angle of center property. means that the measurement of the central angle is twice the measurement of your angle at the circumference. So if 49 degrees is the measurement of the angle in the circumference, twice that measurement, that's the measurement of our central angle. So we have 98 as the measurement of our central angle. So angle M has a measurement of 98 degrees. So let's solve for the angle N. You can either choose to use the chord property, or you can use already the angle of center property. You will be having the same answer. Pero kung gagamitin yung chord property, di ba, chord property, when they are sharing the same chord, that angle have the same or equal measurement. Kung gagamitin ang angle of center of property, get the half of the measurement of your central angle. You will be having the same answer if either of the two property is you're going to use to solve for your angle N. You're going to use chord property. It's easy, which is 49 is equal to N degrees, or 49 degrees is equal to N. That's for chord property. If you're going to use the angle property to find N, you divide your central angle by 2. That's the measurement of your N, which is also 49 degrees. So it's the same. Either you're going to use the chord property or the angle of center. You will be having the same answer for the measurement of our angle N. Let's have another example. Can I clear with the screen for this example that we have for the circle? So for example, we have this circle. It has a measurement of 49 degrees, and we're going to solve for the measurement of K and the measurement of J. So since we have 49 degrees and we have a central angle, so central angle is twice the measurement of our circumference. So 49 times 2 is equal to 98, the same of what we have a while ago. So to get the measurement of angle J facing your central angle, to get the measurement of this angle, which is angle J, facing the central angle, you twice your central angle. So J, angle J, is equal to 98 times 2, twice the measurement of the central angle. If the angle that you're measuring is facing the central angle, the measurement of that angle is twice the central angle. So 98 times 2 is equal to 196. So that's the measurement of angle J. That's the property of the angle of the center. Okay na? Let's have another example. Let's say we have this circle. Yes, it can be more than 180 degrees. The only thing that will cannot be more than 180 degrees if the line segment or one side of the triangle is the diameter. Yun lang ang hindi pwede mag more than 180 degrees. But the other type of triangle in the circle can be more than 180. Okay? For example, we have this circle. For example, we have this circle and we're going to find the measurement of our angle P using or applying the cyclic quadrilateral. Say that in the cyclic quadrilateral, opposite angle is equal to 180 degrees. So for us to be able to find the measurement of P, which is exterior angle of our quadrilateral, we need to find the measurement of this angle first, applying the cyclic quadrilateral. So opposite is equal to 180. So 180, let's use a symbol for x here, is equal to 104 plus x. So 180 minus 104 equals to x. So we have 176. 176 for this angle. The measurement of this angle opposite to 104 is equal to 176. So kung 176 is the measurement of this angle, so to find the measurement of your reflex angle outside of your quadrilateral, 176 P is equal to 180 minus 176. So P is equal to
4.
4. 76 lang pala, sorry. It's 76 only. So 180 minus 76. 76 degrees. So we have 104 for angle P. Tama ba? 180 minus 76, 104. So that's the measurement for our angle P. Since we have, this is a straight line. The straight line is equal to 180 degrees. So that's how we find for the angle P. We subtract the opposite angle of 104 to 180 to find the measurement of our angle P. Or it has a property, exterior angle of your quadrilateral is equal to its opposite angle. So if you're looking for the exterior angle, it's equal to the opposite angle, which is 104. So, let's have another example applying the property of circle that we have. So for example, we have this circle. So we have a quadrilateral that is drawn inside of our circle. That's a measurement of 63 degrees. And we have the measurement of this angle, which is 74 degrees. And we need to solve for angle A, angle B, central angle that has measure of x, and an angle, different color na lang. Have central angle measures x, for example, we have this triangle and quadrilateral inside of our circle. So we're going to solve for angle A, angle B, and angle X, applying the property of circle that we have, the property of the circle. So let's start solving for angle A. So angle A, applying the cyclic property, opposite angle is equal to 180. So 180 minus 74. So angle A is equal to 106. So that's the measurement of our angle A. So measurement of angle B, the same property, the cyclic of quadrilateral. So 180 minus 63 degrees, which is equal to 117 degrees. That's the measurement of our angle B. And applying to find the measurement of angle X, applying the property of angle of center, that means the measurement of the angle in the circumference is twice or half of our central angle. So 95 divided by 2, since that is the measurement of our central angle, I mean circumference angle. So 95 divided by 2, which is equal to 47. Not divide, times multiply by 2, twice the circumference. So 95 times 2, which is equal to 190 degrees. So that's the measurement of our angle X, angle A, and angle B, applying the property of circle, which is the chord property, the angle center property, and the cyclic quadrilateral property. Okay. So tomorrow we're going to continue our discussion about circle.